Let's talk about continuous functions. Here is a definition. A function is continuous at a given point if all of these three conditions are satisfied. If the function can't meet one or more of the conditions, then it is discontinuous. There are two types of questions based on the given function's graph and expression. First, by the function's graph. Let's take a closer look at the behavior of these graphs at and near x equals 2. In definition, these three conditions, we can just call them three steps. The first graph, here is the asymptote line. We know f of 2 is undefined. So we can just stop here. This is discontinuous. Actually, this function does not meet all three conditions. The limit does not exist, dne, because the left one goes to negative infinity and the limit from the right side go towards positive infinity. So the full limit, dne, and of course the third condition can't be satisfied. This graph, here is an open dot, open point, broken point, or hollow point. We know f of 2 is undefined, and this graph is not continuous. Even the limit does exist. You know the left and the right both approach 3. The last one, f of 2, is well defined because this is a jumping point, and the limit does exist from the left and the right. The limit is 2. For this graph, it does not hold the third condition. You know the limit is 2 and the f of 2 is 4. This is discontinuous. By analyzing these graphs' behavior, no holes, no broken open hollow points, no jumping points, no gaps, then the function is continuous. Here we have a tip. If you draw the graph without lifting your pencil from the paper, then the function is continuous. So like follow this path, then you want to come here, you definitely lift your pen. Right? This for the little circle, you follow along this curve, then you have to lift your pen, then draw this remaining part. So the jumping point is the same thing. Next, for type 2, by the function's expression. The key point is based on the domain. There are three cautions for the domain. First, if the variable in the denominator, then we know the denominator can't be 0. And the second, in the radical even radical, inside the even root, like a square root, can't be negative, has to be positive or equal 0. The third caution is for the log. The argument part has to be positive. Here we only focus on the first caution because we are working on the rational functions. The first one is a polynomial function. X can be any real numbers. So it meets all three conditions. All the points can be approached, also can be arrived. The second one, we see the caution, x can't be 4. G of 4 is undefined, so it is not continuous. If you are interested, you can go verify this limit does not exist. We know the left limit goes to positive infinity, the right one is negative infinity, so limit does not exist. So this function can't meet all three conditions. It is discontinuous. This one, we see the quotient, the denominator can't be 0. X can't be positive 2 and negative 2. So H2 and H negative 2 both undefined. So we could just stop here. This function is not continuous. For this piecewise function, consider this point at x equals -1. It is well defined at this point because we see the equal sign. Let's take a look at the limit. We found the left and the right limits. They are not same. So this piecewise function can't satisfy the second condition. It is discontinuous. Let's summarize what we've covered. A function is continuous at a point. No holes, gaps, and jumps and breaks. All these three graphs are discontinuous. We have two conditional statements, necessary, sufficient conditions. If a point is in the domain, then it is not necessary that the function is continuous. However, the backward is right. If the function is continuous at the point, then it is clear that the point is in the domain. So see the reference here. Necessary, sufficient conditions. Let's move back to this example. F of 2 is 4 is well defined due to this jumping point. But this function is not continuous. So 2 is in the domain, but it is not necessary to guarantee the function is continuous. For piecewise function, always discontinuous at the jump discontinuity.